Pozdravljeni v oddaji Spotlight. Kako bodo Slovenija in tudi druge države ob naraščajoči porabi električne energije, pritiskih na energetsko varnost, razvoju digitalne infrastrukture, potrebah industrije in zelenem prehodu zagotovile stabilno, zanesljivo in pa konkurenčno oskrbo z elektriko? Ena od možnih prihodnih rešitev za brezogljično energetsko prihodnost so mali modularni reaktorji. O tej rešitvi so govorili na današnjem dogodku Britansko-slovenske gospodarske zbornice v okviru podnebne pobude Chapter Zero Slovenija. Eden glavnih evropskih igralcev na tem področju je britanski Rolls-Royce, ki je v svoji družbi Rolls-Royce SMR sklenil strateško partnerstvo s češko energetsko družbo ČEZ. V okviru partnerstva je ČEZ pridobil 20% lastniški delež v podjetju Rolls-Royce SMR. Cilj partnerstva je postavitev flote malih modularnih reaktorjev s skupno močjo do 3 gigavate, kar naj bi prispevalo k energetski neodvisnosti Češke ter prehodu v brezogljično družbo. Se bo SMR tehnologija v prihodnosti poslužila tudi Slovenija? O razvoju malih modularnih reaktorjev bo za Bloomberg Adrio govoril Alexis Honor iz podjetja Rolls-Royce SMR, ki je sodeloval tudi na današnji debati. Pozdravljeni, welcome, Mr. Honor.
Thank you very much for having me. Good morning.
Good morning. So what is the timeline? When could the first SMR become operational?
So at the moment, our first planned SMR is due to become operational in 2035. That is in line with the UK government's programme by Great British Energy Nuclear for our first reactors in the UK.
How does Rolls-Royce SMR leverage its industrial and aerospace heritage to accelerate the transition from concept to commercialization compared to maybe its competitors?
That's a great question. There's two key parts that our parent company Rolls-Royce brings to the table in Rolls-Royce SMR. The first is the nuclear submarines. Rolls-Royce PLC has developed and run and manufactured nuclear reactors for the UK submarine fleet for nearly 70 years, almost the first SMRs, if you will. Secondly, our civil aerospace business is well familiar with delivering product at speed, utilising a global supply chain. The Rolls-Royce SMR philosophy is based around building products in a factory that are then shipped to site and assembled rather than built as a one-off infrastructure product. We are here to build a product and we are developing the tools and the capability to do so. This will allow us to deliver SMRs faster than traditional large infrastructure projects and in a way that can deliver future capacity and energy quickly to customers.
How much funding are you investing in their development, and maybe what incentives is the British government providing for this project? Has a final investment decision already been made?
So we've initially invested between our shareholders and a grant from British government, 500 million euros approximately, in the Rolls-Royce SMR design and licensing process in the UK. The UK government recently awarded us a contract for the initial work for our first 3 plants at the Wilfer site in Wales. That contract will pay to the order of £2 billion for the maturing of the design through to completion and take us to a final investment decision in the late 2020s. We are also receiving the first money from the Czech Republic, where we have recently signed the contract for the Temelin programme, which will be our 4th power plant and hopefully the first of up to 6 power plants in the Czech Republic as per the agreement with the UK and Rolls-Royce SMR.
Regulatory frameworks for nuclear energy vary from country to country. Does regulation represent maybe a bottleneck for development, and how are you addressing this challenge?
Regulation, you're quite right, does vary. And it's really important that each country takes responsibility for its own regulation. At Rolls-Royce SMR, we have a great advantage in the UK in that we have something called the generic design assessment that's run by the Office for Nuclear Regulation. That assessment allows us to regulate the plant against a fictional generic site and set the boundary conditions for that site ourselves. What that means is that we can regulate the power plant up to a point where you only need a small amount of site-specific design to move to a different site and place the power plant on different sites in the UK. When that goes abroad, that becomes a little more complex. But what we are doing to try and help with our regulation in other countries is we have invited a number of international regulators to observe our process. Whilst the processes aren't the same in different countries, what it means is they are familiar with the product, they're familiar with our documentation and our design safety criteria and everything that goes with that. And hopefully that then allows us to not do the process differently, but allows us to deliver things and have familiarity to speed up that process and therefore meet each independent country's requirements.
You are cooperating, already, as we already mentioned, with Chase on the SMR development project. What about other countries? Are there any specific countries that are currently expressing concrete interest in deploying them?
Absolutely. So obviously the project in the UK and follow-on units there. But at the moment, we're in the final stage of the competition in Sweden, being run by the Swedish government and Vattenfall for initial 3 SMRs, and we are optimistic about our chances there. We are engaged widely across the Central, Eastern and Southern European regions with a number of countries, Slovenia included, who are showing real interest in deployment of SMRs, not just in terms of ambition, but now in concrete policy plans with funding attached.
In Slovenia, preparations are, as you already mentioned, Slovenia, but the preparations are underway for the construction of the second unit at the Krško nuclear power plant. Can SMRs be co-located along a conventional large-scale nuclear power plant?
Absolutely. So, in theory, anywhere you can put a large nuclear power plant, you can also put SMRs, and that's one where the site at Wilfer in the UK is demonstrating this. It used to have a large nuclear power plant on it that is being decommissioned. It will be replaced with a number of SMRs on that site. So definitely we could co-locate. That being said, a clear advantage of SMRs is the smaller size enables us to deploy on sites that maybe aren't suitable for large nuclear power and co-locate near industries or towns perhaps that want district heating to be able to give us a wider range of uses both on the grid but also behind the meter for private industrials.
What is the potential of SMRs in decarbonizing heavy industry, and what maybe kind of interest are you seeing from energy companies and other industrial giants?
Yeah, the decarbonisation is a big challenge. The electricity for the grid is only a very small part of our dependence on fossil fuels and obviously also our energy security. Decarbonising is something that we can enable via a number of routes. The power plants obviously provide consistent baseload electricity, which when we look at things like data centres and the advent of AI, provides the consistent power that those data centres need in order to be able to operate. SMRs also produce heat, however, so we are able to supply heating to industrial for processes such as fertilizer production for steelworks, etc. And as part of that, we're able to deliver hydrogen. Hydrogen is produced incredibly cheaply by using nuclear technology and that combination of heat and power that nuclear can deliver. And of course, hydrogen is essential not just for burning for high-intensity heat processes, but actually to existing industries like oil refining, where it's needed for cracking. So there's a whole range of potential industries that are interested in SMRs, and we are already talking with a number of different companies, particularly, I would say, in the data center sector, looking at SMRs to support their future deployment.
What does the development of the SMRs mean for the global energy scene, and maybe what impact is expected on energy prices? Will prices initially be higher due to high R&D costs, and maybe when could we expect a positive impact on global energy prices from SMRs?
So prices for SMRs, one of the advantages of nuclear is that when the plant is built, the price is stable. It doesn't change. It stays stable because the cost of energy just continues onwards. The biggest challenge for nuclear has always been in terms of delivering on time and on budget. And this is where our approach to a modularized power plant is hopefully going to deliver those cheaper electricity prices over time. We very much recognize at Rolls-Royce SMR that the first few units are going to be more expensive to build and they are going to take longer to build. And we must be honest about that as we come down the learning curve to reach what we call nth of a kind. And that is when power plants are lower risk because we've proved them in building them in some of our early countries such as the UK, the Czech Republic and Sweden. Once we get into that and we are widespread and delivering fleets across Europe into the mid and late 2030s and even beyond, then the price of electricity will be coming down because the cost will be coming down. I would add that our power plant has been, I beg your pardon, I would add our power plant's been designed from the outside with outset with a levelized cost of electricity at the focus. So we are here not to provide a unique technology or something very clever, but something that will deliver low cost electricity in a comparable space to renewables in the long term.
In light of this geopolitical turmoil that we see, energy independence has become a matter of national security. Maybe how is this affecting your discussions with other European governments, and how is the Rolls-Royce SMR ensuring the stability of its own supply chain to guarantee some, let's say, long-term security for its customers?
It's a really good point. Energy security is clearly at the forefront of all our thinking over the past few years through multiple global events. Rolls-Royce SMR see that nuclear, and in our discussions with customers, nuclear is a key way of countries being able to take ownership of their own energy security. It provides, our plant uses standard fuel, which can be sourced from multiple different countries and locations. And it is something that can be run in the country independently with their own security of supply because it uses well-known, well-understood components. For us, energy security is therefore about being able to operate independently, but also being able to cooperate. So deploying fleets of power plants based on a common production model is really important, and having supply chains that have capacity and redundancy to build those power plants is something we are building in Europe. For us, as the only European designed and manufactured SMR, it's really, really important that we understand how our security of supply supports our European customers and how we can keep ourselves to be independent from perhaps some of the more volatile parts of the world at this time and in the future.
Okay, Mr. Honor, thank you for this conversation and all the best in future as well.
Thank you very much for having me.
Thank you. Mali modularni reaktorji ali s tujo kratico SMR so zagotovo ena od možnosti, ki bodo krojili tudi našo energetsko prihodnost. Hvala, da ste spremljali oddajo Spotlight in nasvidenje.